Hello everyone and welcome back to the Wayfair Coding Academy Python tutorial series. In this video we're going to be covering something called the init file. And no, I don't mean this init file, I mean that init file. And that may sound like a really bad inside joke for Python programmers, but no, there actually really is a difference between the two. But before I can get into this topic, we're going to have to do a bit of a recap on a previous video I did, because this actually correlates to a previous topic, and that is importing custom submodules. In this video, I demonstrated how you could separate and organize your Python code into different files, and how to connect them together using import statements. Now obviously when the video first came out, and many of you were probably still very new to Python, there was something here that you probably did not notice in the directory structure. Even now, you probably still have not noticed it, but that's okay. That's the point of this video, is to highlight what is missing here, and that is the init.py file. Now other viewers may actually be familiar with this file and are probably wondering, well, why is it not there, and how does this code work if it's not there? And that's because at some point Python stopped requiring the file to exist in order for importing submodules to work properly. This happened at Python version 3.3. Before 3.3, Python required an init file to exist in every directory that contained Python code that was going to be used inside the Python program that you were writing. After 3.3, they implemented something called namespace packages. Basically, namespace packaging allowed Python to scan directories to recognize them as Python modules for your program, so you didn't have to implement the init.py file anymore. This created a separation between two different types of packages that you could build in Python: regular packages and namespace packages, with regular packages being Python programs that still use the init.py file. But despite having a new way to create Python packages, one that does not need init.py file, most if not all developers still highly recommend just building regular packages, which basically means you still should use the init.py file. Now, unfortunately, I don't know too much about namespace packaging myself because I am one of the developers who still chooses to build regular packages. So I unfortunately cannot really tell you a lot about what namespace packaging is, other than that it doesn't require the init.py file anymore. However, there is tons of reading material online that basically explains the full differences between the two and why you would choose one over the other. And most of the time, a lot of developers are saying, use regular packaging, use the init.py file. And it's for that reason why that I'm making this video to help explain what the init.py file is and how to make use of it. Now for our first example, I'm going to demonstrate the most basic use for an init.py file, and that is basically to just exist. For this first example, we have a main file and an init file inside the parent directory, and in the subdirectory pilot, we have a pilot file and another init file. Now you're probably wondering, well, what's in these init files? Well, for the most basic use of an init.py file, which is basically to just exist, they're pretty much empty. Both of them have nothing in them. And that is because their most basic purpose is to help Python identify directories as modules within your program. Before Python 3.3, the only way for Python to identify directories as submodules for your program was to have this file. The reason why there are multiple init files is that for regular packaging, you must have an init file in the parent directory and for all subdirectories within that program, all the way down to the lowest subdirectory. So if you accidentally left out an init file in a directory that needed to be a module within your program, Python would ignore it and your code would not get imported, and that would cause runtime issues. After Python 3.3, it wouldn't have mattered if you've forgotten one or not. Python would still read that directory in as a module. However, it's highly advised against using regular packaging and namespace packaging together within a single program. Do one or the other, not both, because it can cause problems for both yourself as well as the people who will be using your program, especially if it is a library meant to be used within other programs. Now you're probably wondering, well, does it look any different when you use init.py files versus when you don't? And the truth is, no. If I were to run this program as it is right now with the init.py files, we get this print statement. Now if I were to remove both init.py files so that we no longer have them here, and then run the program again, it still runs. In fact, in this most basic example here, if I were to add an init file back in and then run the program again, as you can see, it still runs. So on the surface, there really is no difference between using init.py files versus not using init.py files. It's just what's going on under the hood. That being said, init.py files can do a lot more than just helping Python identify which subdirectories need to be modules within your program. And that is because the init.py file is still technically a Python file, and therefore we can absolutely put Python code inside of it, which is what we're going to demonstrate in this second example here. Now our second example is for the most part the same as our first example, save for a few changes. And one of them you've probably already noticed, and that is the import statement in our main file. In the second example, we simply have from pilot import pilot. But in our first example, we had to specify from pilot.pilot import pilot. So why is it we only have to specify from pilot import pilot in our second example? And the answer is the change we made in one of the init files. Now the init file that's on the same level as main is still empty. We don't really have to do anything with that just yet. But the init file that's in the pilot directory, we've added one single line of code. And that is this line right here. From .pilot, import the pilot class. Now first, what is that dot before the pilot? That dot allows us to do explicit relative imports. So instead of specifying the entire module and submodule path to a specific import, we can use the dot to tell this program to import, relatively speaking, from this file. In this case, we are importing from the pilot file to get the pilot class. And we have a reference to the pilot class within this init file now. Now, I don't know if this is the fully correct way to explain this, but I do think it makes it a little bit easy to understand what this is doing. But basically, the init.py file inside the pilot directory is representing the pilot directory as a whole. When you run a program and when you're importing stuff, the very first thing the Python loads up is the init.py file. So when you first run the main.py program, the first thing it does is it loads and executes the init.py file, not the main.py file like you think it would. And that's the same thing for all the subdirectories. When you import from a subdirectory, the first thing it does is it looks for an init.py file, and if it finds one, it will read it in and then execute the code inside of it before doing anything else. So in this line right here, when we say from the pilot directory or the pilot module, import the pilot class, we are basically saying, hey, from the init.py file that's inside the pilot directory, import the pilot class that we imported right here in this line. So when we import this pilot class here, we make it so that it is available for this line right here to import it into this file. And that is why we're able to keep our import line here nice and simple like this, instead of looking like this one right here. While it may seem like a small thing, that's actually a pretty big benefit with using init.py files like this, is that you can keep all your import statements relatively clean and simple to use by not having to write them all like this. Especially when you're writing programs that are going to be actual Python programs and therefore have entry points, because then that's going to be a lot longer. But as you can see, when we run the program, it still runs just fine. Our third example here is pretty much the same as the second example, except we're going to show it off with a bit of inheritance. So for the most part, it's the same, except we're using ships instead of a pilot. So in the main file, you can see I'm importing a cruiser class from the ship module. And inside our ship module, we have our parent class ship, which just basically has a name and a type, and it has a magic method for string representation when we put the object into a print function. And then we have our child class cruiser that inherits from ship. And inside we call our super, we add an extra little line here where the cruiser has a crew count. And then we have our init.py file that's inside the ship module. The init.py file that's on the same level as the main file is still empty. We're not really doing anything with that yet. But in this one, we are importing both the ship class and the cruiser class from the respective files. And in this situation, order matters. Order matters everywhere in Python, but especially here. You have to make sure that the ship has been imported before the cruiser, because when Python loads the cruiser class in, the first line it's going to execute is from ship import ship, which means it is going to look into this init file here and look for the ship class. And if the ship class has not been loaded into the Python program before the cruiser class has been loaded in, then it's going to cause an error and crash the program. I know that seems like a very simple thing for me to really hammer in, but it's always important to make sure you write things in the correct order. And that goes double for any variables and objects and stuff you might also define and create inside an init.py file, which you absolutely can do, and is something I'm going to demonstrate in later examples. And when I run this program, we get Polaris Exploration class with 10 crew members aboard. Now, in our next example here, it's pretty much the same as the previous example, but it's just to demonstrate what else you can put inside an init.py file. Again, we're just focusing on the one that's inside of the ship directory. As you can see, I've added two new things. I've added a variable called crew roster max, and I've added a class definition called crew roster. Both of these are utilized inside of the cruiser class definition, where when I pass in my crew count, I check to see if it's less than the crew roster max. If it's lower than the max, then it will create our crew roster object, and if it's greater than the max, then it will throw an exception. And as you can see, these items can pretty much be imported in the exact same way. Now, you might notice that the syntax highlighting is just highlighting these as white and not in green or anything like it normally would when you do import statements like this. And that's because the syntax highlighting on VS Code doesn't seem to really recognize these two definitions here unless it's actually set up to be a entry point type of program, like it's set up to be an actual regular package. The next example will actually show this exact same type of code with a standard entry point kind of setup, and the syntax highlighting will work for these two items, but in this case, it doesn't. So don't really freak out if you're writing code similar to the way I'm writing the code for this example, and these don't highlight in a certain way. It sees them. It can see these items from the init.py file. The VS Code syntax highlighting is just not recognizing that as such. Now, is this normal code, and would you do this? For variables, absolutely. The crew roster max, making variables like that, that's absolutely perfectly normal and fine to do. It's also perfectly normal and fine to define functions or even call functions. In fact, a really good example for the init.py file that's on the same level as main is calling functions to initialize your logging setup if you're going to implement one. For class definitions, however, it's a bit iffy. Is it okay to do so? Technically, yes. And there are cases where it absolutely makes sense to do so. Like, for example, maybe there are objects that don't really fit anywhere else. It doesn't make sense to give them their own dedicated file or anything like that. They're relatively small classes and it just doesn't really make any sense to do so. Then that would be a perfectly good situation where it would make sense to define the class inside of your init.py file. This particular class definition I have in this example right here is probably not the best way to demonstrate that, but it does demonstrate that you can in fact define a class inside an init.py file and it will work. And of course, once again, order matters. So if it's going to be utilized by any classes that you have to import through this file, make sure you define that class first and make sure you define those variables first as well. So when I run this program, it pretty much runs the same. Polaris Exploration class with 10 crew members aboard. The only thing that's really different is what's going on under the hood. Inside the cruiser class, when it prints out the crew count, it's accessing the variable inside the crew roster object. And just to show how the exception will be raised if you give it too big of a crew size, we'll give it a crew size of 30. And then run it again. And as you can see, the crew roster size has exceeded the limit. Now in this example here, we're going back to the pilot class. And on top of that, we're going back to our roots here, where both our init files are empty, which means that we have to go back to importing our pilot class by accessing the pilot.pilot module. But you also will have noticed that I have this module right here before the pilot.pilot module. And that's because this example right here is the first example to demonstrate how init.py files work with programs that are set up to be built as regular packages. As far as building regular packages go, I will be going into more detail about that in future videos because it's going to be a whole thing on its own. But just to give you a basic idea of how it works, one of the main differences here is that instead of a main.py file, we have a main.py file. And yes, I am absolutely reusing the joke from the beginning of this video. When you want to build a regular package, you have to create a main file in this manner because that is how Python recognizes the entry point for your program when it builds the package. It really doesn't change too much of how you write your code, save for how you do your import statements, which is you have to specify the name of the main module, which is usually the name of your program, and then specify any modules that will be contained within the program. So instead of just specifying pilot.pilot, I would have to specify entry point example one.pilot.pilot because entry point example one is the name of the folder that is containing my regular package. And as you can see, it is incredibly wordy. I mean, of course, part of that is because I chose a horrible name to name this folder to represent this lesson, but that's my own fault. But this example right here is more to show that init.py files pretty much work the same way in a project folder where your program is set up to be built as a regular package, which I will demonstrate here. And don't worry about this command. The pymo part is just an alias I have for executing Python modules. And I will go into more detail on how executing Python modules work in a future video as well. There is really no way to avoid getting into this confusing topic without properly demonstrating in .py files. So don't worry about being confused. I will demonstrate it in future videos. But as you can see, after I run the program, it prints out the statement Captain Crozo of the Polaris, which is the string I have set up in the pilot class. And then in this next example here, it's pretty much the same as the previous example, except this time our init.py file that's contained in the pilot directory will have the line from .pilot import pilot. And that is so we can get rid of that extra pilot and this import line in main so that it's not as wordy as it could be. I know it's not that huge of a difference, especially since I chose a horrible name for my main module, but as you can see, it does make things a little bit simpler and a little bit cleaner. So when I run the program, it's still pretty much the same. All we really did was change how the import statements work. And for this last example here, we're going to be looking at how the init.py file can be used for storing and accessing metadata. And this is the example where the init.py file that's at the same level as the main.py file is actually put to use here. So this example is once again set up to be built as a regular package. And as a result, we have to import our data starting with our main package name, which in this case, I have named metadata underscore example. You will also have noticed I have a line here that says import metadata example. I am importing the main module itself. That is something you absolutely can do. Remember a few examples ago, I did say that an init.py file technically represents the module that you are importing from. So when I say import the main module, I am basically saying import the init.py file that's at the same level as our main file so that I can access any variables, functions, classes, as well as metadata that is stored inside of it, which in this case is just a bit of metadata. I have our main program's docstring at the very top. So when I access our docstring variable here, that's going to print out. And then I also have metadata variables for version, author, and license, which will also get printed out here as well. I also added a new class. As you can see, we're back to ships, and on top of our cruiser class, we now have a shuttle class. There's nothing really special about the shuttle class. The only reason I added it was to show another piece of metadata that you can use inside your init.py file, and that is a metadata variable for all. So to understand what this does, you may have likely seen code snippets out there. You might have done this yourself and whatnot, where you have an import statement that says from some module import asterisk. That asterisk is basically a wildcard. It basically means import everything from this module. You may not want someone to be able to import literally everything from that particular module. You may want to limit what it is they will have access to by specifying that asterisk. That is what this all variable does. It allows you to control what can be imported from this module when you specify the asterisk. Now, this does not prevent you from importing specific things by name. Like if you want to still import the crew roster, then absolutely you can say from ship import crew roster. That's still allowed. It just means that if you're going to use the asterisk, the only thing you're going to get out of it, at least in this example, is the cruiser class and the shuttle class, which I demonstrate in the main file here. When I import asterisk from the ship, the only thing I'm going to have access to is the cruiser and shuttle class. In fact, if I try to create a crew roster, the Python autocomplete for VS Code does not recognize it because it doesn't see it as being imported from that import statement because it's not allowed through the asterisk. I would have to import it manually like this. And then I can actually make that object there. And when I run this example, here's our docstring metadata from the init.py file that's in the parent directory with main. Same with the version number. Oh, whoops. I also realized I have a typo here, so let me fix that real quick. That should be license, not author. And then when I run this example, so here's our docstring metadata, and then here's our version, author, and license metadata. And then down here we have our two ships that we created, the cruiser, which is Polaris, exploration class with 10 crew members aboard, and our shuttle, which is Osprey, that is atmospheric class. But yeah, that's how you can make use of init.py files to store metadata. And the doc strings and stuff are not limited to just the init.py file that's at the same level as main. You can absolutely put doc strings for other modules in their init.pys as well. And that's about it for the Python init file. I hope you guys enjoyed the video and you found it useful, and if you did, be sure to hit the like button, and if you didn't, then be sure to hit the dislike button. And either way, be sure to leave a comment below to let me know what you think about the video. And while you're at it, if you want to stay up to date on this tutorial series as well as other tutorial series that I publish on the channel, then be sure to hit that subscribe button so you can stay up to date as new videos come out. Thanks for watching, and until then, I will see you guys next time.